So the chain rule is to take the derivative of a composite function where you have f of g of x, a function inside of another function. So g of x is the inside function, and f is the outside of the function. So you take the derivative of the inside, so g prime of x, and then you multiply by taking the derivative of the outside, so f prime, and then of g of x, so that's keeping that inside function the same. The example, we have y is equal to 3x squared plus 4 to the 5th power. To take the derivative, 3x squared plus 4 is the inside of the function. The 5 represents the outside. So the g of x is the 3x squared plus 4, and the f of x is x to the 5th. Taking the derivative of the inside is 6x. Then multiply by taking the derivative of the outside, so that's a power rule, bringing the 5 in front. Then keeping the inside the same. In the power rule, you take away 1 from the exponent, so the exponent is 4. So the coefficient of 5 and that exponent of 4 represents the derivative of the outside. The 3x squared plus 4 represents the inside. Then simplifying the problem to be 30x times the quantity 3x squared plus 4 to the 4th power. So next problem, the inside function is 4 minus x squared. The outside is the 3 and the 4, the coefficient. Multiplying the derivative of the inside, which is negative 2x, by the derivative of the outside, which is 12, times leaving the inside the same, which is 4 minus x squared. And the new exponent is 3. And simplifying the problem, that'll be negative 24x multiplied 4 minus x squared to the 3rd power. Before deriving this, let's rewrite the function as x squared minus 2x plus 1 to the 1/2. The inside function is x squared minus 2x plus 1. The outside is the exponent of 1/2. Taking the derivative of the inside first will be 2x minus 2. Multiplied by the derivative of the outside, bring that 1/2 in front, keeping the inside the same, x squared minus 2x plus 1. And the new exponent is now negative 1/2. Simplifying by distributing the 1/2, we have the quantity of x minus 1 being multiplied by that x squared minus 2x plus 1 to the negative 1/2. Factoring the x squared minus 2x plus 1 into x minus 1 times x minus 1. Then rewriting the x minus 1 to the 2nd power. And then distributing the exponent, so power to a power will make x minus 1 to the negative 1, multiplying to make x minus 1 to the 0. Rewriting the function as t squared minus 2 to the negative 1/2 power. The inside function is t squared minus 2. The outside is the negative 1/2 power. Taking the derivative of the inside will be 2t. Multiplied by the derivative of the outside is negative 1/2, keeping the inside the same of t squared minus 2. The new exponent will be negative 3/2. Simplifying will make negative t times the quantity t squared minus 2 to the negative 3/2. Or you can rewrite the problem to have negative t over t squared minus 2 to the 3/2. Or you can also rewrite as negative t over square root of t squared minus 2 to the 3rd power. This example, we have a product, which is x squared is the first function, x minus 2 to the 4th is the second function. The inside is x minus 2, the outside is the 4th power. So taking g, which is x minus 2 to the 4th, multiplying that by f prime, which is 2x, plus then the f function, which is x squared, and multiplying by the derivative of g. Derivative of the inside is 1, derivative of the outside is 4, keeping the inside the same of x minus 2, and the new exponent was 3. Simplifying the problem will make 2x times the quantity x minus 2 to the 4th, plus 4x squared times x minus 2 to the 3rd. You can factor the problem, so each term has both a 2x and an x minus 2 to the 3rd in common. From the first term, what's left is 1x minus 2. And from the second term, what's left is a 2x. Then simplifying the factor to make a 3x minus 2.